So I need to do a bit of explanation or theory before I jump into section 5.2, which is called synthetic division. Each of the problems in section 5.2, I'm going to be doing polynomial division, and polynomial division generally is really unpleasant to do. In this section, we learn a new strategy or new technique to do polynomial division that only works for special problems, but when it works, it's way nicer than doing long division. Before I jump into the section, I need to do a lot of just connecting some ideas that you may have not connected before. So there's probably going to be about 15 minutes of just plain theory, and that has to relate division to factoring. So if I give you a division problem, like 6 divided by 2, most of you would know that that fraction reduces to 0. Similarly, if I gave you a division problem like 6 divided by 5, most of you would say, well, that fraction doesn't reduce, which would be fine. If I asked you to do these division problems using long division, this first problem you might have done like this. 2 goes in the 6 3 times, and then you'd go 3 times 2 is 6. You'd subtract the 6 and you get 0. So the fraction 6 divided by 2 comes out to 3, and down here is the remainder, and it's the remainder of 0, and we generally wouldn't write that remainder. This division problem, if you wrote it as a long division as opposed to a fraction, you might go 5 goes into 6, and then you'd go 5 goes into 6 1 times. 1 times 5 is 5. 6 minus 5 is 1. This is going to be the remainder. And if I did this problem like I might have learned in 5th grade, I would say this is 1 with the remainder of 1. So when we do division in this section, in some sense, we're going to be writing our answers as like a quotient and a remainder. So 6 divided by 2 is 3 with remainder of 0. I don't need to write the remainder. 6 divided by 5 is 1 with the remainder of 1. The nice thing about division problems when you get remainders of 0 is they give you a product that somehow are factoring of the numerator. So in a division problem, if the remainder is 0, it gives me a nice way to factor the numerator. Because we can say the denominator times the answer equals the numerator. For this first division that had a remainder of 0, the denominator 2 times the answer 3 equals the numerator 6. In the second problem, because there's a remainder, it would have to be the denominator times the answer plus the remainder equals the numerator. So for this problem, it's not so nice. It's the denominator, the relation between the answer and the numerator. You take the denominator times the non-remainder part of the answer plus the remainder. That will equal the numerator. Here, the denominator 5 times the non-remainder part of the answer plus the remainder is going to equal the numerator. And that's not going to interest us so much. In this section, if we do long division of a polynomial and we get a remainder that's not 0, then that's not going to interest us so much. The interesting thing will be if we do long division with a polynomial and we get a remainder of 0, that means the denominator times the answer equals the numerator, and in every sense, that will give us a way to factor the numerator. Our goal ultimately in section 5.2 is to use division to figure out a way to factor a polynomial that I might not generally be able to factor. Let me refresh your memory on what long division is, and you're absolutely not required to do this, but let me do this problem, x squared plus 3x minus 10 over x plus 5 using long division. We're not responsible for long division, but if I wanted to do this problem using long division, I can, but it's disastrous. To do this problem using long division, I have to set it up for long division by putting the x plus 5 outside my division bar and the x squared plus 3x minus 10 under my division bar. And I'm going to go through this without doing any explanation because you're not responsible for it, but I just want to make the connection between long division with remainder of 0 and factoring. So the first thing I'd put on top of my division bar is an x. I'd multiply this x by that x and get an x squared. I'd multiply this x times that 5 and get a positive 5x. I'd change the signs and combine. X squared minus x squared is 0. 3x minus 5x is minus 2x. I bring down the minus 10. The next thing I'd put on top of my division bar is a minus 2. I'd go minus 2 times positive x is minus 2x. Minus 2 times positive 5 is minus 10. I change the signs and I combine. Negative 2x and positive 2x is 0. Negative 10 and positive 10 is 0. This is my remainder. I've done long division and I've got a remainder of 0. The answer to this is x minus 2. Technically x minus 2 with remainder of 0. The thing about doing long division and getting a remainder of 0, it tells me that the denominator times the answer equals the numerator. When you do long division and you get a remainder of 0, then the denominator times the answer is going to equal the numerator. So if I can figure out a way to do long division and get a remainder of 0, I can figure out a way to factor the polynomial that's in the numerator. If I multiply this out right here, it's going to equal that. I'll show you this real quickly. If I multiply this out by doing firsts are x times x, x squared, outers are x times minus 2, minus 2x, inners are 5 times x plus 5x, last are 5 times minus 2, which is minus 10. I get x squared plus 3x minus 10, which equals the numerator of x squared plus 3x minus 10. So long division that gives me a remainder of 0 gives me a way to factor a numerator. And that's the beautiful thing that we're going to learn. We're going to learn an alternate way to do division of polynomials that doesn't require long division, and that alternate way is going to give us an ability to factor something that I might not generally be able to factor. So now I'm going to teach you what the section has. The section's titled Synthetic Division, and each of the first 10 problems say perform the division using synthetic division. So instead of doing long division, we're going to do division using synthetic division. And if when we do the division we get a remainder of 0, we're going to use that division to factor the numerator. Let me just kind of jump into, let me do problem 1, because my problem 2 is just a little bit different than problem 1, specifically because I have a plus sign in the denominator and you have a minus sign in the denominator. So I'm going to handle problem 1 the best I can. I'm going to do the division that's implied in problem 1. When I did my this made-up problem, I did nasty long division, and we're not responsible for that at all. So problem 1 gave me the division problem, 3x cubed minus 17x squared plus 15x minus 25, and it asks me to divide it by x minus 5. I know that if I get a remainder of 0 when I do my division, that would mean the denominator times my answer will equal the numerator. So we need to figure out how to do this long division, and we're going to use synthetic division to do that. The first thing I'm going to do is I'm going to make my template for synthetic division. My template for synthetic division has a backwards L right off to the left of a long bar, essentially. Above that bar, I'm going to take the coefficients of any term in the numerator of my division problem. And I need to make a place for every power of x. If this numerator didn't have an x to the first power term, I'd have to put a 0 in place of the x to the first power term. But this numerator has every power of x, so I don't need to worry about any trickery. I'm going to put the coefficient of the x cubed term first, the coefficient of the x squared term, the coefficient of the constant, of the x to the first power term, then the coefficient of the constant. That's my template for the synthetic division. I put a backwards bracket, a long bar, take the coefficients of the numerator, and then in this backwards bar, I'm going to change the sign of the number after the x in the denominator. The sign was -5. I'm going to change this to a +5. That's the template for my synthetic division. When I first do synthetic division, it's going to seem strange. It might take 2 or 3 problems to watch before you can do it yourself. So first thing I do is set up my template, and then everything else gets to be repetitive. The very first number, we just bring it down and put it now under the bar that I wrote. So I'm going to bring the 3 down, and the rest of the way is going to be multiply and combine. So the next thing I'm going to do is I'm going to multiply this 5 times 3, and I'm going to write that product, 5 times 3 is 15, underneath the -17, and now I'm going to combine. So the rest of the way after I bring down is just multiply and combine. If the signs are the same, I add. If the signs are different, I subtract when I combine. Here the signs are different. I'm going to subtract. -17 plus 15 is going to be -2. I'm going to multiply and combine again. I'm going to take the 5. I'm going to multiply it by the -2. 5 times -2 is -10. Write the -10 kind of in the next unused space. Combine these. If they have the same signs, I add. Opposite signs, I subtract and take the sign of the larger. 15 minus 10 is going to give me +5. Multiply and combine. 5 times 5 is 25. Combine the -25 plus 25 and get 0. This very last number is the remainder. If it's not 0, it's not going to help me factor. But because my synthetic division gives me a remainder of 0, it's going to help me factor the numerator. To figure out what the 2 factors of the numerator are, one of the factors is the denominator of x minus 5. The second factor is my answer, and I need to transform these 3 numbers, 3, -2, and 5, into a factor that has x's. And I do this by attaching x's next to the terms, starting with one exponent lower than the original x. The original x had an exponent of x cubed. I'm going to put an x squared with the 3. And then I'm going to lower my exponent from an x squared to an x to the first power. And then I'm done with x's because I'm having no more x powers to put in other than x to the 0, which I don't want to have. The result of my synthetic division, this division, 3x cubed minus 17x squared plus 15x minus 25 over x minus 5 equals 3x squared minus 2x plus 5 with the remainder of 0. So I've kind of finished up part A. Problem 1A asks me to perform the division using synthetic division. The answer to the division problem, 3x cubed minus 17x squared plus 15x minus 25, is 3x squared minus 2x plus 5. And I don't have to write a remainder of 0 when there is a remainder of 0. Now I'm going to move on to part 1B. Part 1B says if the remainder is 0, use the result to completely factor the numerator. And I'm going to do that because I know that when I do division, if I get a remainder of 0, then the denominator times the answer equals the numerator. Equals the numerator. Let me try to write that better here. So I know that the numerator, 3x cubed minus 17x squared plus 15x minus 25 equals the denominator, x minus 5, times the result of the synthetic division, 3x squared minus 2x plus 5. This is potentially an answer to part B. I've used the synthetic division to factor the numerator, but I don't know if I've completely factored the numerator. The first term, x minus 5, doesn't have any potential to be factors. There's no common factor. There's no exponent of 2. But this second parentheses may factor, and before I say that this is my answer to part 1b, I should attempt to factor 3x squared minus 2x plus 5. It turns out that that doesn't factor and that this is my answer. But before I say this is my answer to part B, I'm going to attempt to factor 3x squared minus 2x plus 5, and I'm going to do that using bottoms up. I'm going to bottoms up factor. The first step would be to multiply by 3 and rewrite. So I'm going to multiply that 3 and that 5 together and change this to x squared minus 2x plus 15. The second step in synthetic division is where I'm going to find out this is prime. My goal would be to factor this, and I know that my lasts have to multiply to 15, and they have to both be negative. So what I'm going to do after the minus signs is put two factors of 15, two numbers that multiply out to be 15 that are both negative, that have to add to be to negative 2. The factors of 15, negative 1 and negative 15, add to negative 16. Negative 3 and negative 5 add to positive 15. I'm looking for numbers that multiply to 15 that add to negative 2. And because there aren't a pair of numbers that multiply to 15 that add to negative 2, I know that this doesn't factor, which means the whole initial 3x squared minus 2x plus 5 is prime and it doesn't factor. So that the factoring that I came up for the numerator is that factoring, and this is my final answer for 1b. So I did synthetic division, I got a remainder of 0. If you do synthetic division, you get a remainder of 0. The denominator times the answer equals the numerator. And that's all we're trying to get for the first 10 problems. Let me move on to problems 3 and 4. I'll do problem 4, you can do problem 3. And problem 3, your template's going to be slightly different than mine because your number in the backwards L is going to have a negative sign. So as I go to do part 4a, I'm going to do the synthetic division. To do the synthetic division, I'm going to write a backwards bracket and a long line, and I'm going to pull off the coefficients of the numerator, which are 9, negative 18, negative 16, and positive 32. In the backwards bracket, I'm going to change the sign of the number in the denominator from negative to positive 2. Now I'm going to do my synthetic division. My synthetic division starts off by I bring down the very first number unchanged. I leave it completely intact. So that positive 9, I'm going to bring down. The rest of my synthetic division is to multiply and combine. I'm going to multiply this 2 times that 9 and get 18. I'm going to write it right underneath the negative 18. I'm going to combine these. They have opposite signs. They cancel and they leave me with a 0. Now I'm going to multiply and combine again. I'm going to multiply this 2 in the backwards bracket by the 0 on the bottom of my line, and 2 times 0 is going to be 0. I'm going to combine. Negative 16 plus 0 is negative 16. And then one more multiplying. I'm going to multiply 2 times negative 16. 2 times negative 16 is negative 32. 32 and negative 32 is 0. I get a remainder of 0. When you get a remainder of 0, you have to go on and do the part B. Now I need to write my answer to part 4a. And in 4a, the result of my synthetic division, the first number is going to be a 9. It needs an x next to it, and the exponent is going to be 1 less than an x cubed, so it's going to be an x squared. I'm going to bring a plus sign down for in front of the 0. The x is going to get as an x to the first power. I'm done with x's, and I'm going to bring down the minus 16. So I'm going to get 9x squared minus 16. I don't need to write the 0x. So the result of my synthetic division gives me 9x squared minus 16. If the remainder wasn't 0, I wouldn't do part B, but the remainder is 0, so I'm going to do part B. For part 4b, because the remainder is 0, I know that the numerator equals the denominator times the result of the synthetic division. So I know that the numerator, 9x cubed, minus 18x squared minus 16x plus 32 equals to the denominator x minus 2 times the result of the synthetic division. If the remainder wasn't 0, then I'd have to add on the remainder, and it wouldn't really tell me how to factor the numerator. I'm starting part B, but I'm not done with part B. So I've used my synthetic division to factor the numerator, but I haven't completely factored the numerator because what's in the parentheses still factors more. That's a difference of squares. 9x squared minus 16 factors into 3x plus 4 times 3x minus 4. There's no bottoms-up factoring or I can do to do that part because that's just a formula. So the answer to part 4b is that the numerator, 9x cubed minus 18x squared minus 16x plus 32, it factors into the denominator x minus 2 times the factoring of 9x squared plus 16, which is 3x plus 4 times 3x minus 4. Now I'm completely done with 4b. On the next page, I'm going to do number 5 and not do number 6. I don't know that that's a good or a bad thing, but it'll knock out one of your homework problems. So there's probably a glitch. I made a mistake when I did problem 5, and I'm fixing it. I'm going to do 5 as opposed to 6 just to make your life a little bit easier. So for part 5a, I'm supposed to do synthetic division, and if I notice the numerator in the fraction that I'm dividing, it doesn't have an x to the first power term. I have to think of problem 5, part A, as 3x cubed minus 16x squared plus 0x minus 72 over x minus 6. When you're doing synthetic division, you need a placeholder for every power of x. Because the numerator didn't have a first power of x, I put a first power of x with a 0 as a coefficient, because 0x is 0. This problem and that problem are equal to each other. Now I'm ready to set up the synthetic division. So I'm going to take the coefficients, write them above kind of a horizontal line, so 3, negative 16, 0, and negative 72. Change the sign of the factor in the denominator. Put that in a backwards L. Hopefully I'm saying exactly what I did to get this number. You either change the sign or set this equal to 0 and solve for x. But I just took the x minus 6, changed the sign to 6, and now I'm going to do my synthetic division. First part of my synthetic division is to bring down whatever the first number is. I usually put a little arrow to signify I'm bringing this down. And then I'm going to multiply and combine. First multiplication is going to be this 6 times this 3, which is going to give me an 18. Write the 18 in the next place above the horizontal line. If these have the same signs, I add to combine them. If they have opposite signs, I subtract. These have opposite signs, I subtract. 18 minus 16 is positive 2. Next multiplying, take this 6 times this 2, and I'll get a 12. Combine these, same signs. 0 plus 12 is going to give me 12. Last step for my multiplying, 6 times 12 is 72. Negative 72 plus 72 is 0. So the answer to part A, this division, is going to be 3x squared. I start adding x's 1 degree lower than the initial numerator. The numerator started with an x to the third power, so my answer is going to start with an x to the second power. I get a plus sign because the 2 is positive. The next power of x that I would need is an x to the first power. I get another plus sign because the 12 is positive. I don't have any powers of x left over because I have the x to the first power term, so this becomes the constant. And I get a remainder of 0. That's going to be my answer to 5a. So as I go to write my answer to 5a, I can just say the answer is 3x squared plus 12x plus 2x, 3x squared plus 2x plus 12. Done with 5a. Now I need to move on to 5b. 5b I only do if the remainder is 0, because this is if the remainder is 0, use the result to completely factor the numerator, essentially. So when you do synthetic division, if the remainder is 0, then the answer times the denominator equals the numerator. 5b wants me to factor the numerator, and I only go to factor the numerator if the remainder is 0. If the remainder is not 0, then the factoring doesn't really make sense. So I know when I go to do 5b, because the answer to my synthetic division had a remainder of 0, that the denominator, x minus 6, times the answer, 3x squared plus 2x plus 12, equals the numerator. This is likely my answer for part 5b. So likely my answer, because that's not that readable, for 5b is the numerator 3x squared minus 16x squared minus 72 equals to x minus 6 times 3x squared plus 2x plus 12. There's a chance that if you wrote this for an answer, you'd get a point off. That's because this second parenthesis has a square, and it just might factor. This is going to be considered partially factored if the second parenthesis factors into two parentheses. If the second parenthesis is prime, then this is an answer and it's fully factored. So I need to attempt to factor the 3x squared plus 2x plus 12. I'm going to do this by bottoms up factoring. I'm going to multiply by 3 and rewrite. So this is going to come out to be x squared plus 2x plus 36. Second step in bottoms up factoring is to factor. So I'm going to factor this x squared plus 2x plus 36. I don't have to worry about my first. They're going to be a couple of x's because the x doesn't have a sign in front, a number in front of it. My signs are a couple of pluses, and here's where I'm going to slow down. My lasts need to multiply to 36 and add to 2, and that's not going to be possible. The numbers that multiply to 36 are 1 and 36. They add to 37. Those aren't candidates for the lasts. 2 and 18. Those multiply to 36 but add to 20. Those aren't candidates for the last. 3 and 12 multiply to 36, add to 15. They're no good. 4 and 9 and 6 and 6. There aren't any lasts that simultaneously multiply to 36 and add to 2. That makes this line prime, and by default that makes that prime. Because the 3x squared plus 2x plus 12 is prime, I can't break this 3x squared plus 2x plus 12 into two parentheses, and this is actually a perfect final answer for part 5b. If the second parentheses would have factored into two parentheses had it not been prime, then I would have to rewrite the answer with two parentheses after the x minus 6, or since three parentheses. Alright, so I'm going to cut and paste this back into my work. Hopefully it's a reasonably nice fit, and we'll go on and do whatever next problem I decided to do. I don't know if it helps me or you or not me doing some of your odd problems, but I think I'm going to do number 7 as opposed to number 8. And problems 7 and 8 are written with division signs, not written as a fraction. I can rewrite problem 7 as a fraction, and it helps me out. So when I go to do problem 7, I'm going to think of this as a fraction as opposed to a problem with a division sign. And when I write it with a fraction, I really don't need the parentheses anymore. And when I wrote it as a fraction, the 5x cubed plus 6x plus 8 would go in the numerator, the x plus 2 would go in the denominator. I left a gap because the numerator was missing an x squared term, and when I go to do synthetic division, I need to have represented in the numerator every power of x. If there's a power of x that's missing, I need to throw a 0 in for that power of x. Now I can set it up for synthetic division. Real easy to do. To set it up for synthetic division, I would take the denominator, change its sign, put it in a backwards bracket, pull off the coefficients of 5, 0, 6, and 8, and sneak them above the line that I just wrote. Bring down the 5, and now multiply. Negative 2 times 5 is negative 10. Combine, 0 minus 10 is negative 10. Then negative 2 times negative 10 is positive 20. Combine, 20 plus 6 is 26. Then multiply, negative 2 times 26 is negative 52. And 8 minus 52 I think is negative 44, which it is. The remainder is not 0, which is okay. The answer to part 7a, this division, this 5x cubed plus 6x plus 8 divided by x plus 2 equals 2. I'm going to start putting x's here. I'm going to do 1 power less than the original. So this is going to be 5x squared. This is going to be minus 10x. This is going to be plus 26. The last piece is the remainder, and I'm going to put remainder of negative 44. Done with part A. I don't have to do part B, because in part B it says if the remainder is 0, factor the numerator. If the remainder is not 0, we're just going to skip part B. If the remainder is not 0, the synthetic division doesn't help you factor. Alright, so one more problem for this segment of the video, and then we can go to a part 2. I'm going to do number 10 this time and not your number 9. So for my number 10 to do part A, I need to write it probably as a division problem. As a fraction, the division problem as a fraction is going to help me out quite a bit. So I'm going to write x cubed plus 5x squared over x plus 5. And I'm going to put a plus 0x for the x to the first power term and a plus 0 for the constant term. When I go to do synthetic division, every power of x and the constant term need to be included in the numerator. My synthetic division, I'm going to write my backwards bracket and my bar. Inside the backwards bracket, I'm going to change the sign of the denominator and put negative 5 and pull off my coefficients from the numerator, which are 1, 5, 0, and 0. Now I'm going to do my synthetic division. I'm going to bring down my 1. I'm going to multiply negative 5 times 1 is negative 5. Combine, 5 and negative 5 is 0. Multiply, negative 5 times 0 is 0. Combine, 0 plus 0 is 0. Multiply, negative 5 times 0 is 0. Combine and get 0. This is my remainder. What a strange answer. This answer is 1x squared plus 0x plus 0, because this is the x squared term, this is the x to the first power term, and that is the constant term. So this whole division just comes out to be x squared. My answer to part 10a is that this division problem, x cubed plus 5x squared divided by x plus 5, just equals to x squared. That's really kind of a surprising answer. The nice thing about this, since it's a remainder of 0, I know this synthetic division helps me factor. I know that the denominator times the answer equals the numerator, and I don't need to write the 0 parts. So when I go to do part B, I know that the numerator, which is x cubed plus 5x squared, factors into the denominator, x plus 5, times the numerator, or times the answer, which is x squared. I'm going to write that x squared first. So it tells me that x cubed plus 5x squared factors into x squared times x plus 5, and I knew that. I really don't need synthetic division to factor this. I could have factored x cubed plus 5x squared into x squared times x plus 5 just because there's a common factor of x squared. So synthetic division, if something would factor naturally without synthetic division, is not going to give a different answer. When you go to do problem 9, you're going to write this as a division problem. You're going to write it as x cubed plus 0x squared plus 0x minus 27 over x minus 3. And then when you set it up, you're going to change the sign of the denominator and put a 3. Above your bar, you're going to put a 1, a 0, and a minus 27. The synthetic division will get a remainder of 0, and the answer won't factor. When you go to do part B, the denominator times the answer will equal the numerator of x cubed minus 27. And just like in a few of the problems that I tried to factor the answer to the synthetic division and got something that didn't factor, that's going to happen here. Alright, so I'll stop the video now and let you finish this up, and then we'll move on to a part 2 of this video.